Prove the following identities where the angles involved are acute angles for which expressions are defined. Tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to 1 plus sec theta cosec theta. So this CS theta is nothing but cosec theta or cosecant theta. Let's do this. The first thing I will do is that I will convert both the LHS and RHS in terms of sin theta and cos theta. So I'll start with the RHS. So 1 plus sec theta cosec theta I can write as 1 plus 1 by cos theta into 1 by sin theta. So this is nothing but sin theta cos theta plus 1 divided by sin theta cos theta. So this is my RHS. Now I'll work on the LHS. Again I'll directly convert in terms of sin theta and cos theta. So that will be sin theta by cos theta divided by 1 minus cos theta by sin theta plus cos theta by sin theta divided by 1 minus sin theta by cos theta. Now this I can rewrite as, what I will do is that I'll make a common denominator for both sides and then I will flip the fractions at the bottom to the top. So I'll get sin theta by cos theta into sin theta divided by sin theta minus cos theta plus cos theta by sin theta into cos theta divided by cos theta minus sin theta. Again what I have done, this sin theta by cos theta is this, again this cos theta by sin theta is this 1 minus cos theta by sin theta is this term and 1 minus sin theta by cos theta is this term. Now what I will do is that we have sin theta minus cos theta here and cos theta minus sin theta here. I will take these two terms outside. So we will get 1 minus sin theta minus cos theta into sin square theta divided by cos theta minus cos square theta divided by sin theta. Again what I have done, once more I have taken this sin theta minus cos theta term outside, and since this term is not exactly like this, I had to flip this sign to negative. Now what I will do again, I will cross multiply and make the common denominator. So I will get sin theta minus cos theta multiplied by sin cube theta minus cos cube theta divided by sin theta cos theta. Now let us look at this particular part. This is similar to a cube minus b cube, and a cube minus b cube is equal to a minus b into a square plus ab plus b square. And now we have a as sin theta and b as cos theta. We will use this particular form and resubstitute here, and we will get 1 by sin theta minus cos theta multiplied by sin theta minus cos theta into sin square theta plus sin theta cos theta plus cos square theta whole divided by sin theta cos theta. Now we can see these two terms cancel out. Sin square theta plus cos square theta, we will get 1, and so we can write 1 plus sin theta cos theta divided by sin theta cos theta, which is the LHS, and this is nothing but the RHS. You can see LHS is same as RHS. Prove the following identity where the angles involved are acute angles for which the expressions are defined. So we have cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equal to cosecant of A plus cot A. Let's do this. When I was solving this problem, I felt okay, this is a bit tricky and it is not as straightforward as I thought initially it was. So that's why I thought, okay, let me include this problem in this series of problems. So the way I would do is that I will take both LHS and RHS and I will individually convert it into a new form. Let me do that, starting with the RHS. So we have RHS as, so in RHS we have the relation that cot square A plus 1 is equal to cosec square A, or nothing but cosec square A minus cot square A is equal to 1. Now what I will do is that I will use the A square minus B square is equal to A plus B into A minus B form. So I can write cosecant of A plus cot of A is equal to 1 divided by cosecant of A minus cotangent of A. So we have this RHS as same here, it is converted to a new form. Now what I will do is that I will take this particular part and convert into, or convert in terms of sin theta and cos theta. Let me do that. So this will be equal to 1 divided by cosecant of theta, I can write as 1 by sin theta or sin A minus cos A by sin A. So this is nothing but sin A divided by 1 minus cos A. Now the RHS is of the form in terms of sin A and cos A. Now what I would do is that I will rephrase this original question into a new form. That is, we have the RHS here, that is this, in new terms. So what if I divide the LHS and RHS by this particular term? Then what would happen? The RHS will become 1 and we will have a new term in LHS, that is what I did is that I took this cosecant of A plus cot A into this side. This is what you get here. Now what I would do is that I have cosecant of A plus cot A in terms of sin theta and cos theta, or sin A and cos A. I will use it here. So I will get cos A minus sin A plus 1 divided by cos A plus sin A minus 1 into 1 minus cos A divided by sin A. Again, this is my new question. Okay, now I have to prove LHS equal to RHS, right? So RHS is now simply 1. If I can convert this LHS into 1, that means I have solved the problem. So this is my new LHS and I am going to solve it. So this is equal to, I will do total multiplication of both numerator and denominator. I will get cos A minus sin A plus 1 minus cos square A plus cos A sin A minus cos A whole divided by sin A cos A plus sin square A minus sin A. Now I can cancel this cos A and cos A, and so I can write 1 minus cos square A minus sin A plus cos A sin A divided by the same as before. Now this 1 minus cos square A is nothing but sin square A. So I can write sin square A minus sin A plus cos A sin A and the same denominator as before. Now you can see the denominator and the numerator is same, or we can cancel out each other and we will get LHS to be 1, or now LHS is same as this RHS, or we have proved it. If cos A is equal to 4 by 5, then the value of tan A is equal to, we have 4 options. It's a very simple problem, we can quickly do it. Given cos A to be 4 by 5, that means if I construct a right angled triangle, right angled at B, and let this be 4 and this be 5, then we have cos A to be 4 divided by 5, which is this. Now what will be the value of BC? We can use the Pythagoras theorem, or by practice you will know this is going to be 3, and therefore tan A will be 3 by 4. The value of the expression below is cosecant of 75 degree plus theta minus secant of 15 minus theta degree minus tan 50 degree plus theta plus cotangent of 35 degree minus theta. Let's do this. So in this particular problem, we do not know the value of theta. There is no way we are going to substitute the value of theta and find the value of the expression. So that is not the way we have to approach this problem. What we have to do is that we will have to reduce this expression to a simpler form and see whether we can find the value of it. Again, any approach to find the value of this expression is not possible by substituting the value of theta, because we do not know about the value of theta. So we will have to reduce this expression to a simpler form and see. Let's do that. What I would do is that I will convert this cotangent and secant into sin theta and cot theta form, and let's see. 1 by sin 75 plus theta minus 1 by cos 15 minus theta minus tan. Now I will rewrite this 55 plus theta as this. Observe, tan 90 plus theta minus 35 plus cot 35 minus theta. Again, now I will rewrite this 75 plus theta as below. 1 by sin 90 plus theta minus 15 minus 1 divided by cos 15 minus 30, 15 minus theta. Now I can keep this theta minus 35 in brackets, just isolating. I'm just isolating this theta minus 35 here and theta minus 15 here, so that we convert into the form tan 90 plus theta or sin 90 plus theta. Now what is tan 90 plus theta? Tan 90 plus theta is equal to minus cot theta. Tan 90 plus theta is equal to minus cot theta. So we use this identity to reduce this particular term. minus cot theta minus 35 plus cot 35 minus theta. Again, what is sin 90 plus theta? Sin 90 plus theta is equal to cos theta. So I can write 1 divided by cos theta minus 15 minus 1 by cos 15 minus theta plus cot theta minus 35. This I can write as cot theta minus 35. I am taking negative sign outside this so that we will have negative here and this will be reversing the positions. Why? Because cot minus theta is equal to minus cot theta. And that means these two terms will cancel out each other. Now we have only these two left. Now again you see we have the expression cos minus theta is equal to cos theta. That means I can rewrite this expression as 1 by cos theta minus 15 minus 1 by cos theta minus 15. So this way I transform into this particular form. Both will result in the same value. And now we have two identical terms. I can cancel out and the overall answer of the expression will be 0 or option B. Given that sin theta is equal to A by B, then cos theta is equal to, again a simple problem. So it's given sin theta is equal to A by B. So I can construct a right angle triangle, and if this is theta, then I can write this to be A, B, and let this be a capital A, B, C. So what is the value of AB? AB will be equal to square root of B square minus A square. That means cos theta will be equal to AB by AC, or nothing but root B square minus A square divided by B. Option C. If cos alpha plus beta is equal to 0, then sin alpha minus beta can be reduced to, we have 4 options. Again in this problem, we do not know the value of alpha and beta, and therefore we cannot actually evaluate the value of sin alpha minus beta. So the way we have to think is that how can I convert this cos alpha plus beta into the required form of sin alpha minus beta. Let's do that. It's given cos alpha plus beta is equal to 0. What does this mean? This means that alpha plus beta is equal to 90 degree. Okay, clear? Because we know that cos 90 equal to 0. If cos alpha plus beta is equal to 0, that means alpha plus beta is equal to 90 degrees. Now I will manipulate this equation. I can write as alpha is equal to 90 minus beta, or alpha minus beta is equal to 90 minus beta, or alpha minus beta is equal to 90 minus 2 beta. Now we have to do sin alpha minus beta is equal to sin 90 minus 2 beta, and what is sin 90 minus theta? Sin 90 minus theta is equal to cos theta. That means this expression is equal to cos 2 beta. Therefore the answer is option C, or cos 2 beta. The value of tan 1 degree into tan 2 degree into tan 3 degree all the way up to tan 89 degree is See, right from the start we can understand that there is no way we can evaluate by substituting the values of tan 1 degree or tan 2 degree and so on. We do not know this. If you really want these values, we will have to manually construct a triangle and calculate it, or we have to use a calculator, both of which are not possible from an exam point of view. So we have to convert this expression into a form which is simpler and possibly we can evaluate it. Let's do this. So we have the expression as tan 1 degree multiplied by tan 2 degree multiplied by tan 3 degree all the way up to tan 89 degree. Now I'll convert this into sin theta and cos theta terms. That means I'll get sin 1 degree by cos 1 degree, sin 2 degree by cos 2 degree into sin 3 degree by cos 3 degree all the way up to tan 89. Now what I will do is that I will make use of two identities, that is sin 90 minus theta is equal to cos theta. Cos 90 minus theta is equal to sin theta. Remember, we are going to use these two relationship in this particular expression. So sin 1 degree I can write as sin 90 minus 89 divided by cos 90 minus 89 multiplied by sin 2 degree I can write as sin 90 minus 88 divided by cos 90 minus 88. Okay, sin 3 degree I can write as sin 90 minus 87 degrees divided by cos 90 minus 87 and all the terms up till sin 90 minus 46 divided by cos 90 minus 46 into sin 45 divided by cos 45 into, I'll write the terms here. Okay, now I will just write the value as it is. So sin 46 divided by cos 46, okay, into sin 47 by cos 47 into all the terms up till all the way up to sin 89 divided by cos 89 degree. Now we have sin 90 minus theta is equal to cos theta and cos 90 minus theta is equal to sin theta, and I'll apply it to each of these terms all the way up till here. Okay, from sin 45 by cos 45 to sin 89 by cos 89, I'll keep the terms as it is without any change. So I will get this to be cos 89 degree divided by sin 89 degree into cos 88 degree divided by sin 88, like that all the terms up till cos 46 divided by sin 46 into sin 45 by cos 45 into sin 46 by cos 46 all the way up to sin 89 by cos 89. Now we can cancel our terms, cos 89 here, cos 89 here, sin 89 here, sin 89 here. Similarly, we have cos 88 here and cos 88 here, sin 88 here, sin 88 here, and you go all the way, all the terms will get cancelled out. Then you can see cos 46 is cancels out, sin 46 cancels out, remaining you will only have sin 45 by cos 45, and that will be tan 45. And tan 45 is nothing but 1. So the answer to the given question is option B or 1. If cos 9 alpha is equal to sin alpha and 9 alpha is less than 90 degrees, then the value of tan 5 alpha is, how do we solve this? So it's given that cos 9 alpha is equal to sin alpha and 9 alpha is less than 90 degrees. When will cos and sin equate together? We know cos 45 is equal to sin 45. In that case, both the degrees were same as 45, but in this case we have different angles, that is one is 9 alpha and other is simply alpha. So when can cos and sin be same? Definitely alpha is not 45, right? We know cos 45 is equal to sin 45, but here that cannot be happening, right? Because we have 9 alpha here and alpha here. So what we could do, or what we can see, is that we can write, we know cos 90 minus theta is equal to sin theta. Now let us equate these two equations, that is I will equate these two terms and I will also equate these two terms. So sin theta is nothing but sin alpha and cos 9 alpha is nothing but cos 90 minus theta. That means I can write 90 minus alpha is equal to 9 alpha, or 90 is equal to 10 alpha, or alpha is equal to 9 degrees. That means tan 5 alpha will be nothing but tan 9 into 5 45, or tan 45 degrees, or simply 1. So the answer is option C. Any doubt here? See, we know cos 90 minus theta is equal to sin theta, and in the question we have cos 9 alpha is equal to sin alpha. So I can write this equation as cos 90 minus theta is equal to sin theta is equal to sin alpha. That means theta is equal to alpha, and that is how I wrote this equation. That is 90 minus theta now will become same as 90 minus alpha. If triangle ABC is right angled at C, then the value of cos A plus B is equal to, we have a right angle triangle A, B and C, right angled at C. Now we can write angle A plus angle B will be equal to 180 minus angle C, or nothing but 90 degrees, right? So what will be the value of cos A plus B? Is nothing but cos 90 degree, or 0. That is option A. If sin A plus sin square A is equal to 1, then the value of the expression cos square A plus cos to the power 4A is equal to, again a simple problem. It's given that sin A plus sin square A is equal to 1. That means sin A is equal to 1 minus sin square A, or sin A is equal to cos square A. Okay, we have to evaluate cos square A plus cos to the power 4A is equal to, we have cos square A or cos square A same as sin A, and I will use this to rewrite this particular expression. I can write sin A plus sin square A. Okay, once more what I did, cos square A I can write as sin A, and cos to the power 4A I can write as sin square A, and we know that sin A plus sin square A is equal to 1 from this original expression. So the value of the expression is simply 1, or option A.